Now we want to look at the graph and see how these calculations of rates might be accomplished by looking at a graph. Again, we have water depth versus the clock time. We want to look closer at a calculation for the 1, 2, 3, 4th to the 5th, 6th data points. Okay, between the 4th and the 6th data point, remember the 4th data point was 34 seconds, depth of 60 centimeters, and the the 6th data point was 63 seconds, 40 centimeters. We can look over at those data points. Okay, we're looking between the 4th and the 6th data point, corresponding to these 2 points on the graph. What we're going to do is we're going to go back to the graph. We're going to zoom in a little bit on this calculation. By looking at the y-axis, we're going from 60 centimeters down to 40. We see that there's a rise from this point to this point of negative 20 centimeters. The run is from 34 seconds to 63 seconds. We can't see the x-axis down there, but we recall the data set. The run is 29 seconds. So if we go negative 20 centimeters in 29 seconds, what's the average rate at which the depth is changing? Well, we're going to divide the negative 20 centimeters by the 29 seconds. When we calculate a rate, we divide the change in the quantity by the change in the time. For example, if you made $50 in 2 hours, which is pretty good, you'd be making money at the rate of $25 per hour. We divide the $50 by the 2 hours. We divide the change in the quantity by the time. Now, of course, the change in the quantity is represented by the rise of the graph from this point to this point, and the 29 seconds is the run of the graph, so that when we divide the change in the quantity, the negative 20 centimeters, by the change in the time, 29 seconds, we're dividing rise by run, which, as we know, gives a slope. The slope is the rise divided by the run. Negative 20 centimeters divided by 29 seconds, or negative 0.69 centimeters per second.